Hello, mentors. Welcome to meeting 6, modular patterns. So that's February 16th, and this is the second meeting that will be in person. Please complete the module as usual by Saturday, February 12th. And so this is the agenda. We start at 2 with the introduction, then we do the teams or the tables. And these are the two big activities. The first one is called Patterns, Module 5, and it will last about 50 minutes, maximum 55. And you guys will be playing with reduced sequences module 5 and also module 10 and discover lots of cycles. Then you'll do crypto coins, and so it's a cryptocurrency that really grows or falls in insane ways, and the idea is to crack the pattern and to decide if you should invest or not and under which conditions. So let's take a look at the time management as usual. So for the first one, you're expected to have 50 minutes, maximum of 55 minutes for patterns module 5. And then for crypto coins, you should expect 30 minutes or maximum, to end at 3:45, set the usual alarm. Some time management tips. So in part 1, there's a lot of problems, a lot of little things, little, computations, explorations, questions. So don't force yourself to do every single problem, but more try to be guided over quality and guided on how to challenge your students, even if you just do one or two big explorations. But fewer problems may be better. If you start part 2 late, then you can speed up the introduction a little bit. Just put yourself in a position that students start working individually as soon as possible. And so you can be aware of that, and maybe you have a very cool story that would have taken maybe 10 minutes. You can cut it maybe to 4 or 3 minutes, and that's fine because you want to really have kids doing the math and allocating time for kids to explore the problems on their own. That's the most important part. Finally, during the meeting, talk to your commentors about changing any plans. To trust your decisions and learn how to learn from them. So it's very important that you reflect at the end of this meeting. This meeting is all about when and how to move on. That's our principle for the coaching. And so it's really important to talk about which decisions did I make? Would have I made the same decision, or how would I change it? And pretty much why did I make those decisions? And then, if you reflect, then next time you'll be more equipped to really, make better decisions on time management. So as we say, this is the principle, know when and how to move on. Let's look at the problems a little closer, just looking at the, student workbook. And recall that you shouldn't be, having the teaching manual printed up, but more like having maybe a cheat sheet or just quick notes. But everybody will have the, this student workbook, so you can rely on it. Part 1, patterns, module 5. We start with a little what do you notice and what do you wonder and what connections can you make. This is after you just talk a little bit about maybe, little scenarios or cases about, modulo 2 or modulo 3. Let me just put the teaching manual for a second. You can talk about lights on and off, what happens to that, without even introducing the formal concept of modulo. Or if you are with a compass and you do west and rotate 90 degrees, then, be aware of the fact that just 4 rotations are equal to nothing. So 4 equals to 0 in a sense. And so developing this intuition is really important. And then you just jump to module 5. You do this by an exploration in which you have some fingers, some number lines. One is reduced, the other is not reduced. So it's just a typical number line. And then you have some, some other representations. For instance, you could have this spinner in which you just see that you reduce the numbers. You could also have remainder. So this is 18 divided by 5. It's kind of 3 in the sense that you have equal groups of 5, and then the remainder is 3. So that's another connection that students may know about remainder. You could also have some equations, provocative equations that kids may be surprised, but maybe you can make sense of them. And finally, this row. During the meeting, you'll have also some, some bases that will reduce numbers in a way that you rotate the base, and every time you hit 5, it's like you do one full round, one full circle to the base. And you'll have also these spinner wheels, 5 spinner, we call it. So feel free to use all these manipulatives, all these visual tools throughout the meeting because the concept of modulo 5, it's not the hardest thing in the world, of course. It's not also the easiest, but what matters, regardless of easy or not easy, is the more connections you can make to visual tools, to visual representations, analogies in real life, then the more transferable will that be for students, outside of math in their real lives. So it's really important to make a lot of connections. Then you jump to iterations modulo 5, and then you have 4 problems that are, the same style. The first one is kind of easy. The second one is a little harder because you have duplication. And then the third one is harder because you have cases. So if the number is even, you duplicate. If it's odd, you add 3. So we made a video for explaining this. And then number 4, it's the most challenging from this part because you really want to create your own rules. So students create the rules and then they see what happens. Then you jump to part 2 of this, or the follow-up, which is modulo 10. So it's pretty much doing the same. If you find maybe you don't have much time, it may be a good idea to skip modulo 10, but it will depend because it's also a great opportunity to reinforce the idea that the modulo may change depending on if you want to do modulo 5 or modulo 10, depending on how you want to reduce. And it's cool to see these new sequences that are going to be more wild just because you have more numbers from 0 to 9 now. Then part 2, crypto coins. It's a funny puzzle about some coins that says, if your money in dollars is a multiple of 3 any given day, then for the next day, your account gets 14 coins. So that's great. But if it's not, then you lose 10 coins. So it's similar to dollars, just lose 10 coins. So each coin, we call it a crypto, and it's just our units. If you get negative balance, it's like a mirror. So if you got -6, then you automatically, without even passing a day, you get 6 coins. So this is just to prevent that you have a negative balance. So that's great. And then you ask, well, you say you need to keep your money for at least 10 days. This will be important and interesting when the mathematical explorations are done. And then you poll the students if you think it's a good idea to actually open an account and maybe with which value would you do it, and you explore. Creating polls is important because then the students are invested in their first guess or their first intuition, and then they're getting more motivated to, to see if how far they got from their predictions to reality. So can you find any cycles in the sequence of money by changing your initial balance? How many can you find? As you will see in the solutions, it actually happens that it's usually a bad idea to invest because in normal conditions, when you start with a big amount, every 3 days you are losing 6 coins. So even if you start with $1,000, say, then the more days that pass, then less money you get. It's tricky because you would think that, well, 14 is bigger than 10, sorry, and then there's 2 cases. But what happens here is that it's actually much harder. So let me go to the crypto problem. It's actually much harder to be a multiple of 3. So there's only 1 out of 3 situations in which you will earn 14 coins. And then there's only 1 situation. And that's also some probability discussion in sense of, discussing how likely are you to get into a position where your money is a multiple of 3 or not. And all these explorations will be done. And then if you have time, then the question is, how can I change the rules from my crypto problem? So this is giving more autonomy to kids. How can I change the rules, whether the rule about multiple of 3 or the rule about getting these many coins, so that it actually pays off to open this crypto account? And so, for example, if you change 14 to 15, then you would be in a great position because every day you start with a multiple of 3, every day you would get 15 coins. So forever and ever, you would just grow to infinity, so to speak. But if you don't, then maybe you can play around with this 10 number and see what happens, and maybe have some not as ideal condition, but something also interesting. So that's the meaning right there. And another thing that's important when you do the predict, there's going to be a very nice prompt in part 1 that asks about a situation in which you have a slow start and you have to make a time management decision. I won't explain this in the video, but I just want to say that just think really about it, and just, just discuss with your partners, with your co-mentors, how would you make that decision. You don't have to make the same decision that you made in the Pear Deck, of course, compared to the one that you make during the teaching, but it just helps you have more eyes. It helps you have more vision, more angles, more aspects to consider to make the most informed decision. There's lots of variables. There's your student, how much they understand, your commenter, of course, the pace itself. So it's not as easy as in the Pear Deck, of course, but this just helps us plan and just reflect about time management. So that's for now. Enjoy the meeting.